Good morning. Here's the good news. There's two. One, I have no slides. The second is what I'm going to talk to you about, I think will be of personal interest to every single person in this room and your loved ones. And this is not about longevity. I do not like the term longevity because most people that we've done our research on and interviewed actually don't want to live longer for the sake of living longer. They actually want to remain functionally healthy as long as possible. And I think there's an important distinction we need to make for two reasons. One is the scientific pursuit of what we're seeking answers to. And secondly, to get people to understand that this is not about a few billionaires wanting to live forever at the expense of everybody else. That is not the mission. I have the privilege of being the founding CEO of Hevolution Foundation, headquartered in Riyadh. And we are today, as I speak, the second largest funder of aging biology and neuroscience in the world. Second to the US federal government. And 5 years ago, we did not exist. And we continue to grow. And our goal, especially with what's going on in recent times around funding and science, was never to be the biggest, but we are continuing to increasingly fund across the world. And I'm going to talk about three things. Why do we need to do this? The second is, what does our enterprise look like in terms of focus? And the third is, what does the future look like? And what are the non-tangibles that we've already seen in the first 5 years? A common question I get. You've been at this now 5 years. What have you learned? You're going to hear from the panelists who are all experts around the details and the numbers of the demographic change that's going on in the world. When I was a young medical student, we were worried about overpopulation on the planet. Today, the birth rate in countries like India, Pakistan, have dropped from 6 or 7 children per couple down to 3. In the Middle East, they've dropped from around 6 to 2. That is a massive, dramatic decline. In fact, the world's population is approximately plateauing and will start to decline after that. The challenge is we have 1 billion people on the planet over 60. It is projected to be 2 billion by the year 2050, 2060. However, if the population isn't going to be growing, that's about a third of the world's population is going to be, quote, retirement age, whatever you want to look at, if you want to redefine what retirement really looks like. And I'm well past my retirement age. Now, consider I'm now therefore geriatric. This is very personal to me. This is not geriatrics, and I want to acknowledge a number of people, two of whom are in this room, Vice Chancellor Joan Gable, not only our host, but actually a discussion partner of mine when we started this journey of over 4 years ago. And Deborah Wynne Smith, who serves on one of our boards, was also a discussion partner. Thank you for what you helped guide us to. Now, what's the upside from this? Forget the science for a minute. Let's talk about economics. By the best estimates we have, 12-month extension of healthy life, not life itself, but just the healthy part of our life, is estimated by several economists to be worth about $4 trillion of GDP to the United States alone. So we're going to talk about what's the return on investment for research, and in this particular case, health, data, AI, all of this is going to come together. Then the economic argument is extremely powerful. $4 trillion to the US GDP in uplift, both in cost saving but also increased productivity if we can keep the workforce healthy. A workforce that's aging and we need them in the workforce. This is not a case of we're going to have lots of young people taking those jobs, and this is not a lot of old people sitting in jobs that young people could do. That is not the reality of the situation. It may be a political statement, but it's not reality. The second is that we have to ask ourselves, how do we democratize this? If we cannot scale this across the world, the north-south global divide, the east-west divide will continue to widen, and the challenges we're seeing in the world are not going to get any less, likely more. The third is the innovation that's going to be necessary here is not going to come from one center, one city, one country, or even one region. Aging is very contextual. It is not just your genetics that drives your aging, it is also where you age. Even within the United States, there are differences in the rural areas versus the urban areas. We know socioeconomic input is important, we know isolation is important, but even in affluent cities, aging is not equal amongst all citizens, and we need to think about this. Some of the fundamental research around this, we're proud to be funders of University of Pittsburgh's Medical Centers Research Center in aging, and was one of the first centers we were able to give grants to. So this is not new. Now, how do we go about this? We absolutely need government policy to support this. I'll come back to that. We need academic centers to find the solutions. We need the financial sector to invest and back it. And ultimately, we need a regulatory path to market to bring diagnostics and therapeutics to the market. Today, as I speak to you, there is no indication available at any regulatory agency for aging as a therapeutic agent. There is no way to approve a drug to prevent aging, and I'm talking about keeping you healthy. There is no path to market. In the absence of that, we will not get industry to invest. So, there may be some workarounds, and I'll talk to you about those. But in the long run, we need our civic leaderships, our policymakers, to actually align with the future. Here's the reality. Our biggest healthcare expenditure today, Medicare, Medicaid, takes care of age-related chronic diseases. The US NIH, $44 billion enterprise on an annual funding, only spends $4 billion on the National Institute of Aging. Of that, $2 billion is on dementia. Of the remaining $2 billion, less than half is on the biology of aging. So considering our single biggest cost as a healthcare system is the consequences of aging, we spend 5% of our research enterprise on the biology of aging. Makes you wonder really what our priorities are, prevention or intervention at the end of the process. That theme, by the way, carries through in public health in numerous different ways. Now, a little bit of hope. I'm going to give you some case studies of things that my team was privileged, honored to have funded. Completely left field, by the way. We came at this slightly differently. We said, look, what if you said, we're not going to go for aging, but we're going to go for a disease where aging is known to accelerate. And I'm going to mention a disease that is prominent around the world. Most people in this room will not think of it. Today, as we speak, 2 billion humans have been infected by hepatitis B. 2 billion. 350 million humans today live with chronic hepatitis B. There's about 15% of those that get infected. And there is no cure today for hepatitis B. 2 billion people either self-recover, or 1/3 of a billion, that is equal to the United States population, are living with the virus, infecting others, and at risk of liver cancer, chronic cirrhosis, and inflammation, with no therapy available. Hepatitis C has treatment, not hepatitis B. A group of very interesting scientists asked the question, what is it that allows 85% of humans to eliminate the virus and 15% to never be able to get rid of it? The virus is the same. By the way, it sounds like COVID, doesn't it? Same virus, some people die, some people survive. So is it the virus that's different, or is it the host? And then when they further look at this, you actually realize when hepatitis B infects the liver cell, just like other many viruses, the cell ages. It gets older faster. And it raises an interesting question. What is it about the virus interface that causes the aging clock in your liver cells to now suddenly run faster? And as your liver cells get older, their ability to reject the virus becomes diminished. By the way, only 1 in 5 humans over 65 that get the flu vaccine actually benefit. There's something similar. Our ability to respond to a vaccine is diminished at our age than it is when you're 25. So do we need more vaccines, or do we need to make the vaccines we got better and more effective? Which means understand the host. By the way, it's not surprising, our 2 Nobel Prizes recently were on the immune system's regulatory process. We're right at the cusp of that. Where am I going with this? Well, we had the opportunity to invest in this technology. We were funders. We helped support the company that was created out of this university IP. And guess what? They decided to not create another virus toxin, but looked at the aging process of the liver cell through the epigenome and edited the epigenome in mice and showed that if you target the liver itself, target the epigenome, the mouse could get rid of the virus. It cured itself. Now, that's mice. Then they moved on to rabbits, and then they moved on to monkeys. And guess what? The monkeys eliminated the virus, cured themselves of hepatitis B. As I speak today, I'm absolutely delighted to tell you the first humans are being dosed with this treatment with hepatitis B that they are infected with and are now being dosed for the first time to cure hepatitis B. Will it be successful? I do not know. The fact that mice, rabbits, monkeys have been successful gives us a lot of hope. The fact that the regulatory agency has given an IND is very hopeful. By the way, it's an aging drug. It's an aging approach to treat a known chronic disease. What does this mean? The reason I'm bringing this up is what you're not going to be hearing from people talking about longevity is the normal thing that happens with science is not what you came out to go after, but it's the adjacencies and the new avenues it opens up because we're starting to understand the biology of aging and the way in which we age and the way it affects our body. We are now starting to see cures for treatments and, for diseases we never imagined possible. I'm going to give you one other possible example. How many of you heard of psoriasis? Okay, so I'm an endocrinologist originally. I'm a time-expired endocrinologist, so I don't know anything about endocrinology anymore. But it's interesting that we treat psoriasis often with biologics by giving infusions, steroids by giving anti-inflammatories. But if you ever look at a patient with psoriasis, you see this psoriatic lesion, and then you see normal skin all around it. And so it makes you wonder, was it about the skin where you have the lesion, and why is the rest of the skin all normal when this is all going to be a biological process that's affecting the whole body? Could it be a systemic issue, or could it be something specifically localized to those cells? So another group we had the privilege of funding asked that question and said, well, what if we started to understand the senolytic process, or the aging process in the inflamed cells of the skin that are accelerated and older versus the normal cells, and we could start to understand in the same human that difference. Could we come at it with a targeted senolytic rather than a systemic senolytic? We funded that company, and as I speak, they are in human trials to actually go after senolytics, that is the zombie cells, but on a targeted lesion by finding a way. So I'm going to start to give you, hopefully, more questions that I leave you with than answers. That was deliberate. But importantly, the point I want to make is the field of geroscience is here today. We at Hevolution today fund 250 programs around the world. Over 200 in the United States. The first 4 companies we invested in are now in human trials. They've gone from animal to human research. I just talked about 2 of them. We are in the middle of designing the first ever pure intramural research center in geroscience in the world, which will be staffed with faculty that have no teaching responsibilities, which will be staffed by faculty who have no administrative responsibilities. They will have one duty. Think of Bell Labs of aging. You come to work to solve major problems through collaborations across multiple centers, through countries, because we aim to create a global virtual intramural program that connects university systems, all taking researchers around the world working on the same problem. Think of building the Airbus across Europe under one common design system, but actually being built across Europe. Think of that for life sciences research. So, is Pittsburgh great? Absolutely. Could it be better if it was connected to 10 other centers with one common major global problem to solve? A lot better. And that is the future I envision. We envision a very different future where getting old is inevitable. Getting sick as you get old is not inevitable. Thank you very much.